Good morning, my dear students. Welcome to Unacademy. Welcome to Kreatryx channel and welcome to Impulse batch. Before going to start today's session, let me introduce myself. I'm K.V. Swamy. I've done my MTech in Systems and Signal Processing. My favorite subjects include Signals and Communication, and currently I'm associated with Unacademy. And if you want to purchase any course on Unacademy, you can use my referral code KVS Live, with which you will be getting flat 10% discount. Any course on Unacademy you can purchase using the code KVS Live. First of all, we'll observe what are the various courses for GATE we are having in Unacademy. Basically, we are having two types of subscriptions here, the Plus subscription and the Iconic subscription. In the Plus subscription, the student will be exposed to live classes, crash courses, weekly tests, doubt solving sessions, and batches are conducted in both English and Hindi. If a student is not comfortable with English, he can take the batch in Hindi, and if a student is not comfortable with Hindi, he can take the batch in English from his favorite educator, and we have rank improvement batches as well. Coming to the next subscription, Iconic subscription, here a personal coach is allotted to the students who will prepare the study planner. Study booster sessions are there. Separate test analysis is taken for each and every student. Dedicated doubt clearing instructors are there, and preparatory study material is also given to the students. Coming to the fee structure, if you want to take admission in Plus subscription for GATE or ESE for 12 months, that is 1 year program, this costs around 27,225 rupees only after applying the code KVS Live. GATE or ESE preparation in Plus subscription for 18 months, that is 1.5 year program, this costs around 34,650 rupees only after applying the code KVS Live. GATE or ESE preparation in Plus subscription for 24 months, that is 2 year program, this costs around 39,600 rupees only after applying the code KVS Live. In Iconic subscription, if you want to take the subscription for 12 months, it costs around 45,225 rupees only after applying the code KVS Live. For 24 months, it costs around 66,600 rupees only after applying the code KVS Live. And let me tell you an important information, that if you are going to take subscription on today or tomorrow, you will be getting an offer that additional 2 months extra subscription you will be getting for 1 year subscription, and additional 3 months subscription is free for 24 months subscription. So try to utilize this opportunity, my dear students. And Unacademy is going to conduct Unacademy Combat on this Sunday also, that is on 27th of June, for the branches of mechanical, civil, electrical, electronics and communication, computer science and IT. And the advantage with this is, if your rank is in between 1 to 3, you will be getting 100% discount on Plus subscription. If your rank is in between 4 to 10, you will be getting 75% off on Plus subscription. If your rank is in between 11 to 50, you will be getting 50% off on Plus subscription. And if your rank is in between 51 to 100, you will be getting 25% off on Plus subscription. And these are the currently running batches in Unacademy. For ECE, the batch which is going to be started on 23rd of June is Laksha batch for GATE 2022 aspirants, and Arohan batch for 2023 aspirants, and the starting subject is Analog Electronics by Siddharth Sabharwal sir. If you want to take the subscription, you can use my code, referral code KVS Live. And for electrical students, Laksha batch for 2022 aspirants and Arohan batch for 2023 aspirants is going to start on 23rd of June, and the starting subject is Analog Electronics by Siddharth Sabharwal sir. And there is a chance of price hike in the subscription, so try to take the subscription as soon as possible. And if you are going to take subscription today or tomorrow, you will be getting 2 months extra subscription for 1 year and 3 months extra subscription for 24 months. Try to avail this offer, my dear students. And Unacademy is coming with new features known as efficient revision via digital notes in Unacademy app. So it's a new feature in Unacademy. Fine. Right. Good morning, Harish. Good morning, Adarsh. Thank you, Chaitanya Reddy. We'll discuss the problem puzzle now. All of you give your attendance by pressing the like button, my dear students. give your attendance by pressing the like button. Yesterday, what we were discussing, the linearity property of Z transform. What does the linearity property say? Linearity, if you recollect, linearity property of Z transform, it says that if the signal x1 of n forms a Z transform pair with x1 of z with ROC R1, x2 of n forms a Z transform pair with x2 of z with ROC R2, then the linear combination ax1 of n plus bx2 of n forms a Z transform pair with what? Ax1 of z plus b x2 of z with ROC containing R1 intersection R2. Remember, for linear combination you must have common ROC. If common ROC is not existing, means Z transform will not exist for the linear combination. For example, look here, suppose if I take the signal x of n is equal to 1. Now, does the Z transform exist? And remember, my dear students, the Z transform what we are going to discuss now is a bilateral Z transform in which the limits are considered from minus infinite to plus infinite. As we have unilateral Laplace transform, here also we'll be having unilateral Z transform, which we'll be discussing later. So what is the Z transform we are discussing now is with respect to bilateral Z transform. Okay, fine. Now if I want to find out the bilateral Z transform of the signal 1, can you find out? See, do you know the relationship between the signal 1 and u of n? Can I write my 1 as u of n plus u of minus n minus 1? In the initial classes we have seen that the signal 1 in discrete can be written as u of n plus u of minus n minus 1. Hope this is clear. In continuous, suppose if you have continuous time signal 1, how it can be written as? It can be written as u of t plus u of minus t. In discrete, u of n plus u of minus n minus 1. No. Now, does the Z transform exist? See, if you want to have the Z transform for the signal x of n, there must be a common ROC, otherwise no Z transform. What is the ROC for u of n? Mod z greater than 1. U of minus n minus 1 means what is the ROC? Mod z less than 1. Is there any common ROC? No common ROC means no Z transform. Z transform will not exist. Remember, for the linear combination, if you want to calculate the Z transform is common ROC must exist. Common ROC must exist, same as that of Laplace transform. Hope you are convinced with this. Now, let's go to the homework problem. Yesterday I gave you one homework problem. No? Clear? This concept is clear. Please give your reply so that I can move forward. Make this session an interactive one, my dear students. For linear combination, you must have common ROC. Otherwise, Z transform will not exist. Individually, Z transform will exist for the first signal and second signal, but in order for the linear combination to have Z transform means we must have common ROC. Right. See, bilateral Laplace transform 1 also does not exist because u of t ROC is sigma greater than 0, u of minus t ROC is sigma less than 0. No common ROC, no no Laplace transform. Right. If you look at the yesterday's question, what was the yesterday's question? X of n is equal to b power mod n. Listen carefully, my dear students. B power mod n, where b greater than 0. And what I said? Calculate the Z transform. Calculate the Z transform of x of n and comment on the values of b. I said, right? So Fazal has given some answer. Let's verify whether he is correct or not. See, first of all, you must know what is the expansion for b power mod n. See, in continuous case, similar kind of signal is e power minus a mod t, e power minus at u of t plus e power at u of minus t. This is a double-sided exponential non-causal signal, right? Now, b power mod n in discrete is expansion is b power n u of n plus b power minus n u of minus n minus 1. This is the expansion. So again write the expansion here, b power n u of n plus b power minus n u of minus n minus 1. Now try to modify the signal x of n. How you are going to modify? B power n u of n, take minus common. Whenever you have u of minus n minus 1, try to take minus common and try to put in the standard form. I can write it as u of minus n minus 1 like this. Hope this is clear for all of you. Now calculate the Z transform. B power n u of n means this is the form of a power n u of n, no? Z by Z minus B with ROC mod Z greater than B. Mod Z greater than mod A, here mod Z greater than B, minus a power n u of minus n minus 1 Z by Z minus 1 by B, and as this signal is left sided one, mod Z less than 1 by B. Now what is the Z transform? Z square minus Z by B minus Z square plus BZ by Z minus B multiplied with Z minus 1 by B, and linear combination you have to take the intersection of ROCs. B less than mod Z less than 1 by B, Z square gets cancelled, or this results in x of Z is equal to Z times B minus 1 by B by Z minus B Z minus 1 by B with ROC B less than mod Z less than 1 by B. Okay. Now comment on the values of B. How we are going to comment on the values of B? Here my dear students, observe, listen carefully. He said B greater than 0, B greater than 0, but B greater than 0 means it can take any value. Now what happens if I take the values of B greater than 1, and what happens if I take the values of B less than 1? We'll observe. So look here. What happens if B greater than 1? Look here, B greater than 1. Tell me some value of B greater than 1. Type your answer. Tell me one value of B greater than 1. Tell me a value of B greater than 1, my dear students. Two. Very good, Krishna. I am also thinking of the same. Okay, let's B is equal to 2. What will happen? B, let's draw the ROC. Let's draw the ROC. How to draw the ROC? ROC in Z transform is always drawn with respect to unit circle. So take a unit circle. So real part of Z, imaginary part of Z. Right. So B is equal to 2 means what will happen? Look here. First pole is at what? First pole is at what? Z is equal to B. Z is equal to B means at 2. At 2. So along the pole 2, draw a dotted circle, from which if you observe, mod Z greater than B means what? ROC is outside. ROC is outside. ROC is outside like this. Now the next pole is at what point? The next pole is at 1 by b. B is to know 1 by b, from which ROC is inside it. So 1 by b means 1 by 2, from which ROC is mod z less than 1 by b means inside it. Is there a common ROC now? Is there a common ROC? If I take the value of b to be 2, for this linear combination, is there a common ROC? No common ROC. No common ROC means Z transform does not exist. Sorry, Z transform does not exist. So I cannot take the values of b greater than 1. I cannot take the values of b greater than 1. Now what happens if I take the values of b less than 1? Let's verify. B less than 1. Say 1 by 2 I take. Draw the pole zero plot again. Take a unit circle. Real part of z, imaginary part of z. B is equal to 1 by 2. First pole is at 1 by 2. First pole is at b, no? You can observe. First pole is at b, the second pole is at 1 by b. The pole at b has the ROC outside it, and the pole at 1 by b has the ROC inside it. Now we'll see whether we get the common ROC or not. If you are getting common ROC for b less than 1, yes, b must be less than 1. So dotted circle along the pole 1 by 2, from which ROC is outside it. Okay, fine. ROC is outside it. And where is the other pole located? Other pole is located 1 by b. 1 by b means 2. Okay. Along the pole 2, draw a dotted circle, from which ROC is inside it. Yes. Now there is a common ROC. ROC is inside means common ROC. Yes, always here comment on the value of b means b must be less than 1. If b greater than 1, see, we will not have any common ROC and we cannot find out the Z transform. Here comment on the value of b means here b is greater than 0, fine. B must be less than 1, or I can write 0 less than b less than 1. This is the range. Hope you are all comfortable. Right? Clear? Now we can say one point that if you observe here, this b power mod n is a two-sided signal. As this is existing from minus infinite to plus infinite, this is a two-sided signal. And remember, for a two-sided signal, if there is a common ROC, see, ROC forms a ring in the Z plane. ROC forms a ring in the Z plane. For a two-sided signal, ROC for a two-sided signal, if there is a common ROC, ROC forms a ring in the Z plane. Ring. In the Z plane. Similar kind of thing we have seen in Laplace also. For a two-sided signal, if there is a common ROC forms a strip in the S plane. Strip will get there. Here we will get a ring in the Z plane. ring in the z plane. देवांश विशाल सर is teaching, I suppose. पढ़ा रहे वो देवांश. Hope you're all comfortable. Okay. Next question. Find the inverse Z transform of x of z is equal to 3 minus 5 by 6. Very, very important problem. These kind of problems are expected in the exam. Find the inverse Z transform. Come on, take down the problem. Take down the problem. Here, if you observe the problem, find the inverse Z transform. One data is missing. One data is missing. What is that data? Please tell me. One data is missing. In the problem, some data is missing. What is that data? What is that data? I ask you to find out. Yes, exactly. You are right, Harish. ROC is missing. We can find out the inverse Z transform provided if you are given ROC. Yes, exactly. ROC is missing. See, if anybody asks you what is the inverse of z by z minus a means, you should not say the signal what you know, but you must immediately ask, sir, what is the ROC? If you tell me the ROC, then only I can find out the inverse Z transform. Suppose if I say mod Z less than mod A, then you can say, acha, this is minus a power n u of minus n minus 1. Suppose if I say z by z minus a, if mod Z greater than mod A, then only you must say that inverse is a power n u of n. So ROC we must have for calculation of inverse Z transform. ROC we must have. And if you remember, day before yesterday we have seen the synthesis equation for calculating the inverse Z transform, but we won't be using that synthesis equation. Rather, we'll be finding the inverse Z transform using partial fraction approach only. Partial fraction approach. Now try to resolve this one into partial fractions. And look here, ROC is not given, no? ROC is not given means our job is to consider all the possible cases. All the possible cases. For that, how we are going to proceed? First of all, draw the pole zero plot. So take a unit circle. So real part of z, imaginary part of z. So let me draw a bigger unit circle like this. Right. So this is my unit circle. Where are the poles located? Always remember, here coefficient of z inverse indicates the pole. Coefficient of z inverse indicate the pole. So first pole is located at 1 by 3. First pole is located at 1 by 3. 1 by 3 is 0.333. Along the pole draw a dotted circle, and the other pole is located 1 by 4. Along the pole 1 by 4 means 0.25, no? Draw a dotted circle. Now can you tell me from this pole zero plot how many ROCs I can have? From this pole zero plot how many ROCs we can have? How many ROCs we can have? Suppose if you are given a pole zero plot like this and they will ask you, how many ROCs you can have? Yes, 3 ROCs. What are those? What are those? First one is here the ROC from 1 by 3 can be outsided and ROC from 1 by 3 also can be outsider. ROC from 1 by 4 can be outsided. ROC from 1 by 3 can be outsided. In which case we will take the common ROC. So mod z greater than 1 by 3. This could be one possibility. In which case ROC lies outside of the outermost pole. And the second possibility, ROC from 1 by 3 can be inserted and ROC from 1 by 4 also can be inserted. In which case ROC lies inside of the innermost pole. And the third possibility is from 1 by 4 outside, from 1 by 3 inside, in which ROC forms a ring in the z plane. So 1 by 4 less than mod z less than 1 by 3. These are the three possibilities. If I take from 1 by 4 inside, from 1 by 3 outside, means there is no common ROC. So only 3 cases I will be getting. 3 cases I will be getting. First of all, resolve this one into partial fractions. Resolve this one into partial fractions. How you are going to resolve this one into partial fractions? Do one thing. Substitute z inverse is equal to 4 here. Substitute z inverse is equal to 4 so that this term becomes 0. So what are the partial fractions? I think and in the next case substitute z inverse is equal to 3. These are the partial fractions I got. Please confirm whether you also got the same or not. Now if I take the first case, that is mod z greater than 1 by 3. For this one I want to get the time domain signal. Right. Now here x of n is mod z greater than 1 by 3 means from 1 by 4 outsided, from 1 by 3 also outsided. So what is the outside equivalent of 1 by 1 minus 1 by 4 z inverse? Or 1 by 1 minus 1 by 4 z inverse are z by z minus 1 by 4 are same. Remember my dear students that z by z minus a can also be written as 1 by 1 minus a z inverse. Already we have seen this. So what could be the inverse? 1 by 4 outside equivalent 1 by 4 whole power n u of n plus 2 times 1 by 3 whole power n u of n. This is the inverse corresponding to the ROC mod z greater than 1 by 3. Exactly. Mod z greater than 1 by 3. Mod z greater than 1 by 3. And if you observe here, this is a causal signal, no? Here u of n is there, u of n is there. Yesterday we have seen for a causal signal, ROC must be outside of the outermost pole. What we consider now, ROC must be outside of the outermost pole and it includes z is equal to infinite also. It includes the infinite radius circle also, right? So first ROC is completed, first inverse is completed, mod z less than 1 by 4. Okay, next slide I will go. X of z is equal to 1 by 1 minus 1 by 4 z inverse plus 2 by 1 minus 1 by 3 z inverse for mod z less than 1 by 3. Observe here, mod z less than 1 by 4. Mod z less than 1 by 4 means here both the poles are inside. Both the poles, mod z less than 1 by 4 means the ROC from 1 by 3 is inside and the ROC from the pole 1 by 4 is also inside. So you have to write the inside equivalents. So what will happen? What will happen? Come on. Arvind Reddy, it's a stable system you are saying. Stable system in the sense this is corresponding to the signal, no? Stable system means you must be given a transfer function, then only you can comment. Okay, You can comment like whether DTFT exists or not, that kind of comments you can make. And we have separate discussion on stability also. Now what is the inside equivalent? Suppose if I have 1 by 1 minus AZ inverse, mod Z less than mod A, what is the inverse? Minus A power n U of minus n minus 1, right? So minus of 1 by 4 whole power n U of minus n minus 1 inside equivalents you have to take. Hope you also got the same answer, right? Now what is the third one? From 1 by 4 outside, from 1 by 3 inside it. Okay, fine, easily I can know. So third one is x of z is 1 upon 1 minus 1 by 4 z inverse plus 2 upon 1 minus 1 by 3 z inverse. For the ROC, 1 by 4 less than mod z less than 1 by 3 means from 1 by 3 outside it, this is outside, the second one is inside it. Yes, you can draw 1 by 4 whole power n U of n from 1 by 3 inside it, no, minus 2 times 1 by 3 whole power n U of minus n minus 1. Now look here, I got 3 answers. First answer, second answer, third answer. First one, second one, third one. Now my question is you must answer among the three inverse the transforms I calculated, which of the three signals are absolutely summable? How many are absolutely summable? How many are absolutely summable is my question. Or which signal is absolutely summable? Which signal is absolutely summable? Here first, see, first inverse I got, second inverse I got, third inverse also I got. Now which signal is absolutely summable if I ask you? Arvind Reddy, 1 and 2. Okay, any more answers? How many are absolutely summable? How many are absolutely summable? Ramakrishna, 2. See, look here, absolutely summable. Look here, absolutely summable I said. If the signal is absolutely summable, discrete time Fourier transform must exist. If the signal is absolutely summable, discrete time Fourier transform must exist. And what is the relationship between Z transform and discrete time Fourier transform? Z transform converges to discrete time Fourier transform on the unit circle. Listen carefully. Z transform converges to discrete time Fourier transform on the unit circle. The meaning is, if the ROC of your Z transform, contains unit circle, if the ROC of your Z transform contains unit circle for that particular signal, along with the Z transform, discrete time Fourier transform also exists, right? Now if you observe the first one, mod Z greater than 1 by 3, mod Z greater than 1 by 3 means from 1 by 3 outside it, this kind of ROC you are going to get. Mod Z greater than 1 by 3 means this kind of ROC, isn't it? Now does it include unit circle? Yes, it is crossing the unit circle. So definitely for this one, discrete time Fourier transform exists. Discrete time Fourier transform exists and the signal will be absolutely summable. And if you have any doubt, you can draw the signal also. So the resulting signal will be a decaying exponential, right? For the second one, if you observe, for the second, mod Z less than 1 by 4. Mod Z less than 1 by 4 means inside of the innermost pole. Sorry, here inside of the innermost pole means it is not including unit circle. It is not including unit circle means DTFT does not exist. DTFT does not exist, not including unit circle. Now the third one, from 1 by 4 outside it, from 1 by 3 inside it, from 1 by 4 outside it, from 1 by 3 inside it, and is not including unit circle. So this one, ring portion. Does this ROC include a unit circle? No. So DTFT does not exist. You can draw also, you can draw and verify. Only for the first signal DTFT exists, so it is absolutely summable. This is only the signal which is absolutely summable, for which we can calculate the discrete time Fourier transform. For the remaining two signals, we cannot find out the discrete time Fourier transform. Hope this point is clear. Laplace transform converges to continuous time Fourier transform on the imaginary axis. If the ROC of your Laplace transform contains the j-omega axis for that particular signal, along with the Laplace transform, continuous time Fourier transform also exists. In the same way, Z transform converges to discrete time Fourier transform on the unit circle. That is, if the ROC of your Z transform contains unit circle, along with the Z transform, discrete time Fourier transform also exists. Hope this point is clear for all of you. Hope this point is clear. Right. Now in this way you are going to calculate the inverse Z transform. Let me ask you one more question. Given x of n is equal to -1 whole power n u of n plus alpha power n u of -n naught. This is x of n. Determine the constraints on alpha and n naught such that ROC of x of z is 1 less than mod z less than 2. ROC of x of z is 1 less than mod z less than 2. Come on, try to solve this one. Fazal, they will give ROC, Fazal. For sure they will give ROC. See, determine the constraints on alpha and n naught such that ROC of x of z is 1 less than mod z less than 2 is the question. How to solve this problem? Okay, how to solve this problem? We'll do one thing. Forget about the problem for a while. Suppose if I ask you one question. What is the ROC corresponding to 1 by 2 whole power n u of n? ROC I am asking. Mod z greater than 1 by 2. Causal signal. Causal signal means ROC is outside of the outermost pole and it includes infinite. Okay, fine. Now, what is the ROC for this signal? Minus 1 by 2 whole power n u of minus n minus 1. The first one is a causal signal and the second one is a anticausal signal. Anticausal signal means what? ROC will be inside of the innermost pole mod z less than 1 by 2. Mod z less than 1 by 2. Right? Suppose if I ask you what is the ROC for this one, u of minus n minus 2, u of minus n minus 2 if I ask you. So u of minus n minus 2 means still it is the anticausal signal, still it is the anticausal signal. ROC will be mod z less than 1 by 2 only. ROC will be mod z less than 1 by 2 only. Suppose if I ask you what is the ROC for minus 1 by 2 whole power n, u of minus n plus 2 if I ask you. Minus n plus 2. What is the ROC? See, first of all, what is the nature of this signal? U of minus n plus 2 means this exists from minus infinite to 2. Minus infinite to 2. This is non-causal plus left-sided signal. Non-causal plus left-sided. Yesterday I told you, non-causal plus left-sided means ROC will be inside of the innermost pole. ROC will be inside of the innermost pole, but it will not include mod z is equal to 0. So here it will include this ROC will include mod z is equal to 0. This ROC will include mod z is equal to 0. As this has become non-causal, this will not include mod z is equal to 0. That is only the difference. So we'll write mod z less than 1 by 2 only, but here it will not include mod z is equal to 0. That is only the difference. Or I can write mod z less than 1 by 2 also. In this way also I can specify, no problem. Right. So if you observe, irrespective of the values of the shift here, minus 1, minus 2, plus 2, I am going to get the same ROC. I am going to get the same ROC. Right. Now come to our problem. X of n is minus 1 whole power n, u of n, what did he give? Plus alpha power n. So I can write as minus alpha power n, u of minus n naught. What is the ROC for the first one? What is the ROC for the first one? A power n u of n. Mod z greater than mod a. Now second, what is the ROC? Minus a power n u of minus n naught. So irrespective of the values of the shift, just now we have seen, irrespective of the values of the shift, ROC is mod z less than 1 by 2 here. Now here in this case, in our problem, ROC becomes mod z less than mod alpha. Mod alpha. So what is the final ROC? 1 less than mod z less than mod alpha. But what is the ROC he gave? 1 less than mod z less than 2 he gave. Now what is the in place of mod alpha? 2. So alpha is plus or minus 2. Alpha is plus or minus 2, and n naught, it can have any value. You take any value of n naught, this ROC will not change. Already we have seen n naught, you can take any value, ROC will not change. So alpha is plus minus 2 and n naught, it can have any value. Hope you are convinced with the answer. Please reply so that we can move to the next property. Puzzle mod z greater than mod a will take. Mod a is there. So minus 1 cannot come. A power n u of n or minus a power n u of n will have the same ROC, mod z greater than mod a. Puzzle. Look here. It could be a power n u of n, or the signal could be a minus a power n u of n. ROC would be mod z greater than mod a. Please verify, Fazal. For any value of alpha, signal is non-causal or anti-causal, right? Exactly, exactly. Okay. Let's go to the next property. Linearity is completed. Time shifting property. What is this time shifting property saying? It says that if x of n, if the signal x of n forms a Z transform pair with x of z with ROC R, then x of n minus n naught forms a Z transform pair with z power minus n naught into x of z with the same ROC R except for possible addition or deletion of origin or infinity. Time shifting property says that if x of n forms as a transform pair with x of z with ROCR, x of n minus n naught, z power minus n naught into x of z with the same ROCR, but except for the possible addition or deletion of origin or infinity. Sometimes you have to add the origin, sometimes you have to delete the origin, sometimes you must add infinite, and sometimes you must delete infinite. Now what are the examples you can give? Look here. What are the examples you can give? Here, what is the, yesterday we have seen, just I am recalling the yesterday's discussion. What is the Z transform for 1 by 3 whole power n u of n? What is the Z transform for 1 by 3 whole power n u of n? It is nothing but z by z minus 1 by 3. Right? What is the ROC? Mod z greater than 1 by 3. My dear friends, mod z greater than 1 by 3. And what is the nature of this signal? This is a causal signal. Causal signals means what will happen? Causal signal means ROC will be outside of the outermost pole and it will include infinite. It will include infinite, or I can modify my ROC like this. 1 by 3 less than mod z less than or equal to infinite. Hope this is clear for all of you. Right? Yesterday we got the same. Now if I ask you, what is the Z transform for 1 by 3 whole power n minus 1 u of n minus 1? 1 by 3 whole power n minus 1 u of n minus 1 if I ask you. What is the Z transform? Or use shifting property. What is the shifting property saying? If x of n forms a Z transform pair with x of z, x of n minus n naught means z power minus n naught into x of z. Here what is the in place of n naught? 1. So z power minus n naught into x of z, z by z minus 1 by 3. This is 1 by z minus 1 by 3. Yesterday we got the same expression. Now what is the ROC? If you observe, 1 by 3 whole power n minus 1 u of n minus 1 is still a causal signal, because it is 0 for n less than 0, it is causal signal. So this ROC is maintained. Suppose if I ask you this one from the same, if I ask you what is this Z transform for 1 by 3 whole power n plus 1 u of n plus 1, 1 by 3 whole power n plus 1 u of n plus 1. Use your shifting property. X of n, look here, x of n, x of z with ROC R, x of n minus n naught, where n naught value is minus 1. So the property says that z power minus n naught into x of z. Z power minus n naught means z multiplied with z by z minus 1 by 3. But here if you observe the nature, look here, if you observe the nature of this signal, what kind of signal is this one? U of n plus 1 means it exists from minus infinite to, sorry, u of n plus 1 means exists from -1 to infinite. So this is non-causal right-sided. Non-causal plus right-sided. Yesterday we have seen that if the signal is non-causal and right-sided, what is the ROC? Definitely it is greater than, my dear students, it is greater than 1 by 3. Mod z is greater than 1 by 3, but it will not include infinite. So in this case here, if you observe, infinite is removed. Infinite is removed here. So with shifting, see here what is written, except for the possible addition. In the first case, see with shifting, infinite is included here. In the ROC, infinite is included, but in the second case, ROC is not included. So except for the possible addition, in the first case addition, in the second case deletion of origin or infinity. So here infinity, second case infinity is added, third case infinity is deleted. Right. One more example we will see. Now from yesterday's discussion only, do you remember what is the Z transform for 1 by 3 whole power n u of minus n minus 1 array z by z minus 1 by 3. What is the ROC? What is the ROC? Mod z less than 1 by 3. But what is the nature of the signal? This is anticausal. Anticausal means this is signal is 0 for n greater than 0. So it is anticausal. Anticausal signal means what? ROC will be inside of the innermost pole and it will include mod z is equal to 0 also. Mod z is equal to 0. So what will come? I can modify the ROC like this one, 0. So here 0 is there. Suppose if I calculate for this, hope everybody is getting. Now if I want to calculate the Z transform for this one, for the second signal, what is the difference? What is the difference? If I call this as x of n, my dear students, listen carefully. If I call this as x of n, I am shifting left this x of n by 1 unit. So this is x of n plus 1, x of n plus 1. So if you observe here, x of n, Z transform is x of z, x of n plus 1, z by z times z by z minus 1 by 3. But this is still anticausal. This is still anticausal. Anticausal. So what could be the ROC? 0 less than or equal to mod z less than 1 by 3. So here I am shifting. Here I am shifting and I am including 0 here. I am including 0. Suppose in the same way, if I calculate simply yesterday's problems I am recalling, nothing I am doing. So now if I want the Z transform for this one, so if I call this as x of n, if I call this signal as x of n, what is this signal? This is x of n minus 2. Now use the property z power minus n naught into x of z, right? Now what will happen? This has become, see, if I shift this anticausal signal, if I shift the original anticausal signal by 2 units to the right, this becomes non-causal, non-causal plus left sided. So ROC will be this one, it will not include 0. So if you are shifting, sometimes, look here, if you are with shifting, sometimes 0 will be included, sometimes 0 will be deleted. Next problem. This is an interesting one. I want the Z transform. I want the Z transform and the corresponding ROC. I want the Z transform and the corresponding ROC. First of all, my question is, can you write this signal in terms of impulses? Can you write this signal in terms of impulses? Yes. Discrete time signals are represented as sequences. Sequence is nothing but set of samples where the arrow indicates the reference point, sample value at n is equal to 0. Right side of arrow are 1, 2, 3. Left side of arrow are -1, -2, -3 and so on. Now, how can you write this in terms of impulses? 1 is the sample value at 0, del of n. 1 is the sample value at 0, del of n, plus 2 is the sample value at 1, 2 del of n minus 1, plus 3 is the sample value at 2, 3 del of n minus 2. Yes, Pranay, you are right, man. X of z is Z transform for 1, Z transform for del of n 1, use a shifting property, del of 2 is a constant, del of n minus 1 means 2z power minus 1 plus 3z power minus 2. 3z power minus 2. Right. What is the ROC? What is the ROC? How to get the ROC? First of all, this is a finite duration signal. For finite duration signal, ROC is entire Z plane. ROC is entire Z plane. But what happens if I substitute Z is equal to 0? This becomes infinite, no? So, ROC will be entire Z plane except at Z is equal to 0. Entire Z plane except at Z is equal to 0. And remember, my dear students, very, very important point is this entire plane at Z is equal to 0 can be also be written as mod Z greater than 0. 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 Suppose if I say mod Z greater than or equal to 0 means entire Z plane. If I say mod Z greater than or equal to 0 means entire Z plane. If I remove this, if I remove that equality, equal symbol, so it becomes entire Z plane except at Z is equal to 0. And if you observe, what kind of sequence is this one? The sequence is 0 for n less than 0, no? Or we can write like this also. See, this is a causal finite duration signal. For a causal finite duration sequence, ROC is entire Z plane except at Z is equal to 0. ROC is entire Z plane except at Z is equal to 0. Causal finite duration signal. Suppose the same question if I modify like this. 1, 2, 3, but with the arrow placed at 3. Now this arrow indicates the sample value at n is equal to 0, -1, -2. Now can you write this in terms of impulses? Yes, del of n plus 2. 1 is the sample value at -2, 2 is the sample value at -1, plus 3 is the sample value at 0. Now Z transform is Z square, or using the shifting property, plus 2Z plus 1. Finite duration signal. So the given signal is finite duration signal. So ROC must be entire Z plane, but if I substitute Z is equal to infinite, it blows up, no? So ROC is entire Z plane except at what? Except at Z is equal to infinite. Except at Z is equal to infinite means you can write like this: mod Z less than infinite. Mod Z less than infinite. And remember, if you are writing mod Z less than or equal to infinite means entire Z plane again. If you are writing mod Z less than or equal to infinite means entire Z plane. If I remove this equal sign, it becomes entire Z plane except at Z is equal to infinite. or we can generalize. This is an anti-causal finite duration signal for a anti-causal finite duration sequence. ROC is entire Z plane except at Z is equal to infinite. ROC is entire Z plane except at Z is equal to infinite. Next one. One, two, three with arrow placed at 2. With arrow placed at 2. Arrow indicates sample value at n is equal to 0. Right side of arrow 1, left side of arrow -1. First of all, try to write the signal in terms of impulses. Del of n plus 1 plus 2 del of n, 3 del of n minus 1. Z transform. Use your shifting property. Del of n forms a Z transform pair with 1. Del of n plus 1 means Z plus 2 plus 3Z inverse. So ROC would be exactly Pranay, entire Z plane except at, see, except at Z is equal to 0 and Z is equal to infinite means the circle of 0 radius and circle of infinite radius are eliminated. Entire Z plane except at Z is equal to 0 and Z is equal to infinite, or I can write like this: 0 less than mod Z less than infinite, 0 less than mod Z less than infinite. If I put equal symbols here, again this becomes entire Z plane. If I put equal symbols here, again it becomes entire Z plane. So generalization for non-causal, for a non-causal finite duration sequence, ROC is entire Z plane except at Z is equal to 0 and Z is equal to infinite. Are you ready to solve one problem? Are you ready to solve one beautiful problem? Take the problem. X of n is equal to 1 for 0 less than or equal to n less than or equal to 5 and is 0 otherwise, and g of n is xn minus xn minus 1, g of n. Find g of z and specify the ROC. Find g of z and specify the ROC. Come on, try to solve this one. Find g of z and specify the ROC. Pranay has given some answer. I want the ROC. Okay, anyway you can calculate this z transform, Pranay, but tell me the ROC. I want in a polished way. Fine, very easy question. Look here. First of all, draw x of n. How to draw x of n? Discrete time signal, independent variable is n. 0, 1, 2, 3, 4, 5. So this is your x of n. Great, fine. What could be x of n minus 1? Delayed version of x of n by 1 unit, no? Which exists from 1 to 6. X of n minus 1. Now do one thing. Subtract the bottom signal from the top signal so that you will get g of n. Subtract the bottom signal from the top signal so that you will get g of n. So what happens? 0, 1, 2, 3, 4, 5, 6. At 0, x of n is 1, x of n minus 1 is 0. X of n minus 1 is not defined at 0, so it can be taken to be 0. So 1. At 1, 0, at 2, 0, 3, 0, 4, 0, 5, 0, at 6, minus 1, minus 1, right? So our signal g of n can be written in, can you write this g of n in terms of impulses? Del of n minus 6 is as simple as that. G of n is del of n minus del of n minus 6. Now let's calculate the Z transform. Del of n means 1 minus del of n minus 6. Del of n minus 6 means using the shifting property z power minus 6. Now what is the ROC? What kind of signal is this one? This is a causal finite duration. G of n is causal because 0 for n less than 0. Finite duration because only 2 samples are present. For a causal finite duration sequence, what is the ROC? Entire z plane except at z is equal to 0 or mod z greater than 0. Mod z greater than 0. Yes, Fazal, you are right. Pranay, you are also right. Mod z greater than 0. Completed? Let's go to the next problem. I want the Z transform of the signal 1 by 5 whole power n u of n minus 3. I want the Z transform. I want the Z transform. See, using two ways you can find out the Z transform. First way is hard work. First way is what? Hard work. Hard work means using analysis equation. First of all, define this signal. This is 1 by 5 whole power n. U of n minus 3 means exists from 3 to infinite. No? So Z transform. So 0 to, not 0 to, 3 to infinite. X of n into z power minus n. In this way, if we approach, you will get the answer, but it takes some steps. This is hard work. Second method is smart work. Smart work means using properties. Now, can I write my x of n like this? N minus 3 plus 3, u of n minus 3. Do you have any objection? No objection. Now bring the constant outside. Now can you use the properties? What is the Z transform for 1 by 5 whole power n u of n? This is in the form of a power n u of n. Z by z minus a, ROC mod z greater than mod a. And as it is a causal signal, it includes infinite also. Now use the shifting property. 1 by 5 whole power n minus 3 u of n minus 3. X of n, x of z. What is the shifting property saying? X of n minus n naught. Z power minus n naught. N naught value is how much? 3 x of z. Still it is a causal signal, mod z greater than 1 by 5. Now include the constant also. So what happens if I include the constant? 1 by 5 whole cube to z power minus 2 by z minus 1 by 5. With hard work also you must get the same answer, that is your homework. Yes Fazal, you are right man. With hard work also you must get the same answer. Now look here. After this, see what is our shifting property saying? X of n minus n naught forms a z transform pair with z power minus n naught into x of z. Look here. Or I can write like, or I can say like this: z transform of x of n minus n naught is z power minus n naught into x of z. What I am saying? Z transform of x of n minus n naught is z power minus n naught into x of z. Alternatively, can I say like this, that inverse of z power minus n naught into x of z is x of n minus n naught. See, whenever I am putting a double side arrow here means what? X of n minus n naught or x of n minus n naught and z power minus n naught into x of z, they form a z transform pair, or z transform of x of n minus n naught is z power minus n naught into x of z. Stated in the other way, inverse z transform of z power minus n naught into x of z is x of n minus n naught. Or I can say in this manner also, that if I want the inverse of z power minus n naught into x of z, do one thing: corresponding to this x of z, get x of n first. If I want the inverse of z power minus n naught into x of z, corresponding to this x of z, get x of n first. In this x of n, wherever you have n, replace it with n minus n naught. Can I say this? Yes. If I want the inverse of z power minus n naught into x of z, do one thing: corresponding to this x of z, get x of n, its inverse first. In this inverse, wherever you have n, replace it n minus n naught. Now look here. Suppose if I want the inverse of z power minus 3 into z by z minus 1 by 5 for mod z greater than 1 by 5. Now I want the inverse. Observe here. I want the inverse of this one. I want the inverse. So z power minus n naught into x of z, what I said? To this x of z, get x of n first. To this x of z, z by z minus 1 by 5 for mod z greater than 1 by 5. What is the inverse? 1 by 5 whole power n u of n. In this x of n, wherever you have n, replace with n minus n naught. Z power minus n naught. N naught value is how much? 3. So wherever you have n, replace with n minus n naught. Observe here. The same thing we got here. Now, can anybody tell me what could be the inverse of, what could be the inverse of what could be the inverse of this one? I want the inverse Z transform. Inverse Z transform. Inverse Z transform. What could be the inverse Z transform? Come on, come on. Look here. I can write this as Z power minus 2 times Z by Z minus 1 by 2. Do you have any objection if I write like this? No. This is in the form of Z power minus n naught into x of Z. In the place of n naught I have 2. So what I am saying, corresponding to this x of Z, get x of n first. 1 by 2 whole power n u of n. In this x of n, wherever you have n, replace with n minus n naught. 1 by 2 whole power 0.5 puzzle. 1 by 2 whole power n minus 2 u of n minus 2. Now, look here. Can anybody tell me what could be the inverse of I want the inverse Z transform now. Mod Z less than 1 by 3. Sorry, this is not this one. Small modification. 1 by. I want inverse Z transform. Inverse Z transform. What I said, the principle is only one thing. Z power, if you have Z power minus n naught into x of Z, means to this x of Z get x of n first. In this x of n, wherever you have n, replace with n minus n naught, I am saying. Right? Now, how can you modify this one? I can modify this as Z power minus 2 into Z by Z minus 1 by 3. What is the inverse of Z by Z minus 1 by 3 for mod Z less than 1 by 3? Mod Z less than 1 by 3. ROC is given minus a power n u of minus n minus 1. Hope this is clear. Minus a power n u of minus n minus 1. Now here, wherever you have n, replace it with n minus n naught. Wherever you have n, replace n minus n naught. N naught value is how much here? Z power minus n naught. N naught value is 2. So minus 1 by 3 whole power n minus 2 u of minus of n minus 2 minus 1. Our signal will become minus 1 by 3 whole power n minus 2 u of minus n plus 1 plus 1, or you can write like this, minus 1 by 3 whole power n minus 2 u of minus n plus 1 forms a Z transform pair with do you have any confirmation? Already we did this one. Already we did this one. This one only, right? Just now we have solved this one only. Not this one, sorry. I think this one. Which one? Minus 1 by 3 whole power n minus 2. Do yes, this one only. Minus 1 by 3 whole power n minus 2 u of minus n plus 1 forms a Z transform pair with Z power minus 2. So 1 by Z into Z minus 1 by 3. The same thing we got. You can verify. We can verify. After this, hope you understood. Please reply so that I can move forward. If you understood, give me thumbs up. Fine. Find the inverse Z transform. Inverse Z transform of x of z is equal to 1 by 1024 minus z power minus 10 by 1 minus 1 by 2 z inverse mod z greater than 0. Inverse Z transform. Inverse Z transform is asking. So what could be the answer? Bring 1024 inside, so that we'll get 1 by 1 minus 1 by 2 z inverse minus 1024 can be written as 2 power 10, no? Z power minus 10 by 1 minus 1 by 2 z inverse. Right. Here, what could be the x of n? What could be x of n? 1 by 1 minus 1 by 2 z inverse. Here, the resultant signal is causal finite duration signal. So, this is 1 by 2 whole power n u of n minus 1 by 2 whole power 10. What is the inverse of z power minus 10 by 1 minus 1 by 2 z inverse? U of n minus 10. One by 2 whole power 10, 1 by 2 whole power minus 10 will get cancelled. U of n minus 10 means the resulting signal will exist from 0 to 9. Right. Completed? See, you may get one doubt here. See, yes, typing becomes difficult. Now you may get one doubt. You must get one doubt here. Look here. What is that linearity property saying? Linearity property is saying that, look here. What is the ROC for this one? Mod z greater than 1 by 2. Look here. You may get this doubt afterwards. See, ROC is mod z greater than 1 by 2. What is the ROC here for the second term? Mod z greater than 1 by 2. So, according to linearity, the resultant ROC must be mod z greater than 1 by 2. But mod z greater than 0 is given. He has given mod z greater than 0. How come it is true? Observe here, my doubt is 1 by 1 minus 1 by 2 z inverse means mod z greater than 1 by 2. Here also for the second term also mod z greater than 1 by 2. But according to linearity, you had, whenever for linear combination of signals we will take the common ROC, no? So if I take the intersection, ROC must be mod z greater than 1 by 2. But he has given mod z greater than 0. What is this one? See the doubt, please reply whether the doubt I am getting here is a valid doubt or not. Valid doubt or not? Please reply. See, for the first signal mod z greater than 1 by 2. Second signal, if I consider this to be causal, for second signal mod z greater than 1 by 2 means linear combination means again I must get mod z greater than 1 by 2, but he gave mod z greater than 0. What is this one? Is it a valid doubt? I assumed that the signals are causal and I am doing all this, but the final ROC is also mod z greater than 0. What is this one? See, that is where you have to understand the linearity property. What is the linearity property saying? If you observe, closely observe the linearity property. Linearity property is saying that A into x1 of n plus B into x2 of n forms a Z transform pair with A into x1 of z plus B into x2 of z, fine, with ROC containing R1 intersection R2. This word is there, containing. ROC containing R1 intersection R2 means the resultant ROC, what you are going to get after linearity, after applying the linear combination, must contain the previous ROC. Look here, it is not, it is not guaranteed that ROC will be R1 intersection R2. See, if you had, what will happen, you know? One example I will tell you. Look here, you must understand like this. Always remember, linearity is the resultant ROC, what you are going to get will contain the previous ROC. Look here, U of n, what is the ROC? Mod z greater than 1. Sorry, here not visible. No? See, U of n, what is the ROC? U of n, what is the ROC? Mod z greater than 1. U of n minus 1, what is the ROC? Mod z greater than 1. Or U of n minus, U of n is mod z greater than 1, U of n minus 1 is also mod z greater than 1. Now what happens if I take the difference? U of n minus U of n minus 1 is del of n. Del of n. Del of n, here what I am doing? I am subtracting. Subtracting means according to linearity I must take the intersection. Intersection means what? Here I am going to get del of n. Intersection means for del of n, what is the ROC? Entire z plane. For, see, for del of n, ROC is entire z plane, no? So here the statement was written that ROC containing R1 intersection R2 means there is no guarantee that whatever the ROC you are going to take in the previous steps, that is going to be reflected in the result, but in the resultant ROC definitely your previous ROC is included. See, ROC is entire z plane means what? Definitely it includes mod z greater than 1, no? ROC containing R1 intersection R2. See, there is lot of difference between ROC is equal to R1 intersection R2 and ROC containing R1 intersection R2. Means, look here, ROC is equal to R1 intersection R2 means definite, it is the intersection of ROCs only. ROC containing R1 intersection R2 means the resultant, see, the ROC may be different. If you add two signals, the resultant ROC may be different, but it contains the previous ROC. It contains the previous ROC. Here, mod z greater than 0 means definitely it contains mod z greater than 1 by 2. Here, entire z plane, definitely it contains mod z greater than 1 ROC. Hope this point is clear. Please reply. See, if the signal x1 of n, listen carefully, one more time I am explaining. The signal x1 of n is having a z transform x1 of z with ROC R1, x2 of n forms a Z transform pair with x2 of z with ROC R2, then A into x1 of n plus B into x2 of n. The property says that A into x1 of n plus B into x2 of n forms a Z transform pair with A into x1 of z plus B into x2 of z. This is a property. See, coming to the ROC, there is no guarantee that ROC is always R1 intersection R2. There is no guarantee that ROC is always R1 intersection R2. But you may get a ROC, but definitely you will get ROC, some ROC you will get. By adding these two signals, you will get Z transform. For that, there will be a corresponding ROC which will include the previous ROCs also. So, the statement ROC containing R1 intersection R2 was written. ROC containing R1 intersection R2, but is not exactly ROC is equal to R1 intersection R2. Example I told you, no, U of n mod z greater than 1, U of n minus 1 mod z greater than 1, right? Now linear combination means if I subtract according to the property, look at, I must take the intersection of ROCs, but U of n minus 1 is del of n whose ROC is entire z plane. Entire z plane. Is there a wrong in taking entire z plane? No, because entire z plane includes mod z greater than 1. So ROC containing R1 intersection R2. So the resultant ROC what you are going to get after this linear combination will definitely contain the previous ROC. So there is a lot of there is a lot of hidden facts are there in the word containing. Containing. Hope you understood. Hope you understood. Please reply. So always write for linear combination ROC containing. Containing means after linear combination you may get a finite duration signal. For that ROC will have some ROC which will contain the previous ROCs also. That is the meaning. So we can also say that x of n is causal and finite duration, so ROC is mod z greater than 0. Yes. Yes, Fazal. Okay. So after the class, just think of this statement containing. If any discussion is required, we'll discuss in the next class. Shall we solve one more problem? Are you ready? Are you ready for one more problem? Okay, we'll do one thing. We'll discuss the rest of the things. One more. Oh, you are ready. So I am also ready. If you are ready, I am also ready. Simple problem I am giving. X of z is equal to 1 plus z inverse by 1 plus 1 by 3 z inverse. For mod z greater than 1 by 3, find x of 0, x of 1, x of 2. Come on, I'll be waiting for your answers. X of z is given, ROC is also given. He is asking us to calculate the values of the signal at the instant 0, 1, 2. He is asking us to calculate the values of the signal at the instance 0, 1, 2. Any answers? So I'll also start doing. Meanwhile, you can join. I want the values of x of 0, x of 1, x of 2. So how can I simplify this one? I can simplify like this. So yes, no, I want the values Pranay here as x of 0, x of 1, x of 2 I want. Now taking the inverse, so inverse Z transform is ROC must be given. He has given the ROC as mod Z greater than 1 by 3. No issues here, no issues here also. So x of n is equal to 1 by 1 minus AZ inverse. Let me recall, 1 by 1 minus AZ inverse for mod Z greater than mod A, it is a power n u of n. Okay, so minus 1 by 3 minus a power n minus 1 by 3 whole power n u of n, and use shifting property. Z power minus n naught into x of z, x of n minus n naught, minus 1 by 3 whole power n minus 1 u of n minus 1. X of 0 is not 0, Fazal. X of 0 is not 0. Please verify. This is the signal x of n. Forget about x of 0, x of 1, x of 2. First of all, you must get the signal x of n. There is a method called long division also, with which we will get the same answers. We will discuss that method later. But as we are discussing time shifting property, try to get the answer using time shifting property. X of 0, yaar, what x of 0 means? Substitute the value of n to be 0. Minus 1 by 3 whole power 0 into u of 0 plus minus 1 by 3 whole power minus 1. N is equal to 0, you substitute u of minus 1. U of minus 1 is anyway 0, no? So this will vanish. Anything to the power 0 is 1. So x of 0 is 1. Means what? If you are going to get this one in your exam, you are going to put a wrong answer. X of 0 is 1. X of 0 is 1. X of 1, you tell me. X of 1. X of 1 means substitute the value of n to be 1, or this is minus 1 by 3 whole power 1 into u of 1 plus minus 1 whole power 0 u of 0, or this is minus 1 by 3 plus 1. How much you are going to get? 2 by 3. 2 by 3. Harish, be careful, yaar. 2 by 3. X of 1 is 2 by 3. Come on, tell me the value of x of 2. Tell me the value of x of 2. X of 2 value, you tell me. Pranay, please verify, is it 2 minus 2 by 9? X of 2, I think it is minus 2 by 9. Please verify, Pranay. Is it minus 2 by 9 or 2 by 9? I got minus 2 by 9. Please verify. X of 2. Yes, minus 2 by 9. Good, Vamsi. Good, Vamsi. So x of 0 is 1, x of 1 is 2 by 3, x of 2 is minus 2 by 9. Now, I don't want to leave you with empty hands, but with some homework I want to leave you. Same 1 plus 1 by 3 z inverse, mod z less than 1 by 3. This is homework. Mod z less than 1 by 3, and I want the values of x of 0, x of minus 1, x of minus 2. These three values I want. X of 0, x of minus 1, x of minus 2. These three values I want. Same expression, but I changed the ROC. Same expression, but I changed the ROC, and these three values I want: x of 0, x of minus 1, x of minus 2. Okay, so that's all for today's class. Tomorrow I'll be discussing scaling in Z domain property, time scaling property, time reversal property, differentiation in Z domain property, and if time permits, we'll discuss the convolution in time property of Z transform, which is very, very important. So please refer linearity once and study that statement containing. These are our channels, and you can follow me on Unacademy, unacademy.com, Swamy. So my dear students, please like the session, share the session, subscribe, and don't forget to press the bell icon so that you'll get regular notifications on the sessions. Okay. Tomorrow we'll meet and we'll discuss many questions. Thank you.